Welcome back everyone. By this time we already know what are basis vectors and how important is a basis set while defining any vector space. In today's video, we will study change of basis. We will see what happens to a vector when we change the basis set. So without any delay, let's dive in. We will start with a basic example first. So let us suppose this is your house. Okay. Now, if you need to give the coordinates, let us suppose you are living in a 2D world and your house is also 2D, and you need to give the coordinate of your house to someone. So how you are going to give the coordinate? Right. So you need to first define a coordinate system, right? You need to first define a coordinate system because you need to first define a origin. Then only with respect to the origin or the coordinate system, you will be giving the direction vector of your house, right? So uh, let us suppose you use this standard system, the XY coordinate system. Okay, let us suppose you use this standard coordinate system. Okay, now let us suppose this house is a kind of a point object, and this is the vector. This is the vector pointing to your house. So let us suppose this is the vector pointing to your house. All right. Now let us suppose instead of using this coordinate system, which is the standard XY system, though this is x-axis, right? This is x-axis, and this is y-axis. All right, and here are your standard basis vector, right? So this is I hat, and this is I hat, right? And this is j hat. Okay, so according to this coordinate system, your house, I think, is living somewhere here. So 1 2 3, I think it's 3 comma 2. Okay, so you give this coordinate. Okay, my house is at location 3 comma 2 with respect to this coordinate system. This is standard coordinate system with I hat and j hat as a basis vector. All right. Now let us suppose instead of using this coordinate system, now I use another coordinate system. I use this coordinate system. All right. I remove the previous coordinate system and now I'm using this coordinate system. Okay. Now, one thing you need to notice is that the location of house doesn't change, right? The physical location of house is still same. The physical location of house is still same. You just change the coordinate system. It doesn't change where your house is located. So your physical house is still same. So the vector, if you just remove this coordinate system or everything, this I had, j had, and 3 comma 2, everything. So the house remain at the same location, and even the vector pointing to the house, if this is the origin, even the vector pointing to the house from origin remains same. It doesn't change, is it? No, because the location of house is not changing. Then how the vector? You keep the origin same. You just changing the x and y axis. You rotated them, but you keep the origin same. So if you keep the origin same and the location of house is still same, then the vector pointing to the house still remains same, right? So now in this new system, this 3 comma 2 is no more valid. Why? Because your new coordinate system, maybe this is your new x-axis. So maybe let us suppose this is your x bar axis, new x-axis, okay, and this is your y bar axis, your new y-axis, okay. So let us suppose this is your new I hat. So I am saying it as I bar, and this is your new j hat. So I am saying it as j bar. So according to this coordinate system, what is or this basis basically this basis set, your the coordinates of the your house is no more 3 comma 2. It is, I think, somewhere around 2.5 comma minus 1, somewhere around that, right? So you see, you change the basis set, or coordinate system. For now we can use it interchangeably. You change the coordinate system, but the location of house doesn't change. The physical location of house is still the same, and the vector, even in this case also, the vector pointing to the house remains same. Why? Because you change the I hat and J hat. You rotated this coordinate system by 45-degree anti-clockwise. So here I rotated it 45-degree anti-clockwise. So this is a 45-degree anti-clockwise rotation, AC rotation. We call it AC rotation, anti-clockwise rotation, right? So you just rotated it, so origin remains same. So if origin remains same, so the direction vector to your house also remains same. Its coordinates got changed because your coordinate system, your x-axis, y-axis, your basis set I had, j had got changed. Okay, so similar thing happens with change of basis also. So whenever we change a basis set, the vector, the physical location of the vector remains the same. It's just that its coordinates got changed. Okay, so let us suppose this is your standard basis system. This is your standard basis system, and you are taking this vector. Okay, this is your vector of interest. Okay, so let us suppose in the standard basis system, what is this vector? This vector is 1 comma 2, right? This vector is somewhere, this vector is uh 1 comma 2. All right, so these are the standard basis vector. Okay, so this is the standard basis vector for this basis system, which is I hat. Okay, that is 1 comma 0, and this is j hat. So we can see using this standard basis system in which I hat is 1 comma 0 and j hat is 0 comma 1. This vector is 1 comma 2, right? So I need to move 1 unit in the direction of I hat and 2 units in the direction of j hat. All right. So here V is nothing but a linear combination of I hat and j hat, right? So in this V is a linear combination of I hat and j hat, right? So I can simply write V as I hat plus 2 times j hat, right? I hat plus 2 times j hat. Now we introduce this another system, we call it Bruce basis system. So let us suppose Bruce is a secret service agent. Okay, Bruce is a secret service agent and he need to send coordinates. We are living in a 2D world, by the way. We are living in a 2D world, and Bruce is a secret service agent and he is giving coordinates of a target. Here your target is sitting. All right. Here your target is sitting and he is giving you the coordinates of the target. So because he need to be sure that this coordinate of the target doesn't go in wrong hands. So he need to be sending in such a way that even if someone got those coordinate, they won't be able to decode it. So, for example, he already told me, who is living in the standard basis system, he already told me his basis vectors. Okay, he already told me what are his basis vectors, and now he's sending this the coordinate of this vector. Okay, so let us suppose these are the basis set for Bruce system. Okay, so we call it uh, the first basis set as E1. Okay, so this is this one. So with respect to us, what is this? With respect to our standard basis system, this is minus 1 comma 0. All right, and E2. With respect to our standard basis system, this is 1 comma 0 only. Sorry, 0 comma 1. This is 0 comma 1. Okay. So he already told me these basis set very secretly. He already told me these basis set very secretly. So here this vector which Bruce is referring to, let us suppose I call this V in the standard system as Vs. All right, this is Vs. This is Vs, and this is Bruce system VB. So in his system, this is not 1 comma 2. This is actually minus 1 comma 2. All right. If you see the physical vector, both are pointing to the same point. This vector 1 comma 2 and this vector minus 1 comma 2 are pointing to the same point in this 2D world where origin is same. In both the system, standard basis system and basis Bruce basis system, the origin is fixed. It's just that the basis vector got changed. Okay. So in my system, the standard basis system, the basis vector is this 1 comma 0 and 0 comma 1. And in Bruce basis system, the basis set are minus 1 comma 0 and 0 comma 1. But the origin remains same. And if the origin remains same, then the direction vector to that point remains same. If you just see this vector and this vector, they are exactly same. Okay, they are exactly same, but their coordinate is different. Why? Because we are using different basis sets. Okay, so here what is VB? Here what is VB? The vector VB is nothing but is a linear combination. It is a linear combination of these basis vector E1 and E2. Right? So I can write VB as this is how I reach to this point VB. I need to move minus 1 in the direction of E1. So it is minus 1 times basis vector E1 plus then I need to move 2 times in the direction of E2. Right? 2 times in the direction of E2. This is how I'm going to move. Right? I will first from here I need to move in this direction which is nothing but minus 1 times E1. So I will first move minus 1 time E1. That is I will take minus 1 step in the direction of E1, then I will reach somewhere here, right? I will reach somewhere here, and from this point I need to take two steps in the direction of E2. That is two steps in the direction of E2. So I will take the first step, I will reach here, and I will take the second step, I will reach here. Right? This is how this is what a linear combination means, right? This is how you reach the target point, right? So now let us suppose there is someone who got this coordinate. Okay, Bruce is our spy agent and he send us this target coordinate minus 1 comma 2. Okay, and this target coordinate minus 1 comma 2 reached to us, but in between this transfer someone kind of hacked the message. Okay, and they also received this coordinate minus 1 comma 2. But we are relaxed. Why? Because this minus 1 comma 2 the vector minus 1 comma 2 is not in the standard basis system, it is in Bruce basis system, and the basis vector are very secretive because we haven't transferred this basis vector at all. He told me those basis vector very secretly. Okay, so only me in this world knows this basis vector, no one else knows this basis vector. So the exact position will be decoded only and only by me because I am the only person who knows this basis vector apart from Bruce. So only and only me and Bruce are able to decode the exact coordinates, no one else. So let us suppose some another country's spy agent got this coordinate minus 1 and 2. So the first thing they may think is this vector is somewhere this vector is nothing but this, right? They may think this vector is this. Why? Because in the standard basis system this is minus 1 comma 2, right? In the standard basis system this is minus 1 comma 2. So in this system this is minus 1 comma 2. Okay, so they may think that the target location which Bruce is sending to me is sitting somewhere here, but no. Why? Because they don't know what is Bruce basis system. They may be assuming okay this they are using standard basis system only. But I know the correct basis for Bruce system, right? So I will decode it. I know that okay for him I hat and j hat is not this but this. So I will able to decode it properly. So now we will see how I am going to decode this vector which minus 1 comma 2 which looks like somewhere here. This looks like somewhere here minus 1 comma 2 but it is not here. Okay, so let's see. Yeah, before moving forward, I just need to make one correction. This is not even hat and E2 hat. So uh, for Bruce, okay, for Bruce, this is even hat. All right, this is even hat and this is E2 hat. So for him, even hat is 1 0 and E2 hat is 0 1 only. All right, for him, even hat is 1 0 and E2 hat is 0 1 only. In his system, this 1 0 is not according to our system. Then you will be saying, okay, if I hat is 1 0, it is here. then how could be even hat is here? So this is according to the standard basis system. This is according these 1 0 and 0 1 according to this standard basis system, and this 1 0 and 0 1 is according to this basis system. So for him, even had the first basis vector is 1 0 only and e2 hat is 0 1 only. Okay, so that's how we get to this vector, right? That's how we get to this vector VB. So what I said, -1, we need to move -1 in the direction of even hat. So what is even hat? For him, the first basis vector is 1 0 only, and two times in the direction of the second basis vector, which is 0 1 only. So if you multiply and add, you will get -1 times 2. That is here. You move -1 times in the even direction, and then you move two times in the e2 direction. You get to this point. Okay. The coordinate which I stated earlier, that is this -1 0 and 0 1. These coordinates are nothing but the basis set of Bruce system with respect to our standard system. So these are even hat and E2 hat with respect to our standard system. With respect to our standard system. So we will use these even hat and E2 hat in with respect to our standard system to convert the coordinate. Okay. So let's see how we will get this vector, the vector for the target location in our basis system. Okay, so this VB, which is -1 comma 2, right? So we already know the basis set of Bruce system with respect to our standard system. All right. So this basically means we need to. It means move -1 along the first basis along this -1 comma 0, that is the transformed uh, basis set, and then move move 2 units along 0 comma 1. Okay, so I can write this as PB is -1 -1 comma 0 plus 2 units in the direction of 0 1. So this is -1 comma sorry, +1 comma 2. So this is this is the same VB but in our standard system. All right. So this is V. Here is V. So basically, when Bruce is saying -1 comma 2, he doesn't mean this vector. He doesn't mean this vector. He doesn't mean this location. He's actually conveying me this position. That is this vector 1 comma 2. Okay. So although V is 1 comma 2 in one system and -1 comma 2 in another system. So V is different is the value of V is different in different coordinate system. But the vector V, if you see the vector V, it lies at the same location when we remove these lines. Okay, when if we remove these grid lines, if we remove these uh, x-axis and y-axis, these coordinate system, if we just see this vector V, then it is lying at the same location. So no matter which basis set we are using, because origin is fixed. Okay, origin is always here, just the basis set changes. So no matter which basis set which basis we choose, the numeric value will differ according to the basis set, but this vector lie like this in space. Okay, no matter which basis we choose, this vector will lie like this in space. Okay, so we have seen how we converted this vector -1 comma 2 from Proust system to R system, standard basic system. So we can generalize this. So we can convert any vector VB which is in Bruce system to R system, standard system VS, using this matrix, using this way matrix where the columns where the columns represent where the basis vector of Bruce are lying in our standard system. So this is where even hat, which is Bruce first basis vector, is lying in our standard system, right? And this is where E2 hat is lying in our standard system. Okay, so this is the matrix. This is the matrix which we are going to use to convert any vector from Bruce system to R system. Okay, so you can see that because we know what is the basis set for Bruce system with respect to R system, what is the basis set for Bruce system with respect to R standard system. Because we know this, that's how we are able to correctly decode what he is trying to say. He is not saying this vector, he is not pointing to this target location, but he is pointing to this target location because we know the correct system. Okay, so if I generalize this, I mean, or if I summarize this, whatever I said. So let us suppose when Bruce tells this coordinate, that is -1 comma 2, right? We think we think this. What we think when Bruce tell -1 comma 2, we think this, right? Because our system is a standard system, so we think, okay, -1 is somewhere here, -1 is somewhere here, and then we move 2 in this direction, so we will get somewhere here. Okay, because we are using our standard basis set. So we think this because for us I hat is here and J hat is here, somewhere like this. But because Bruce is not following I hat and J hat, hence this is interpretation is wrong. So we will ask Bruce that what is his basis vector. Okay, we know what are the basis vector of Bruce system. Okay, so this is the first basis vector, that is even at which is this, right? And this is the second vector basis vector which is E2 hat, right? So we already know this. Bruce already told us this, right? So Now we will use now we will use this matrix which I already told that we know we need to convert this basis vector in our system. So which is -1 comma 0 and E2 is 0 comma 1. So this is what I just stated here. So we will use this matrix to convert -1 comma 2. Okay, and we will get we will get 1 comma 2. Okay, so Bruce is actually conveying this, that is 1 comma 2. So we can see that how we need to translate vector from Bruce system to our system. Okay. So what if we need to do inverse of it? So let us suppose I am trying to send some message to Bruce that okay, the next target location is somewhere here or something else. Okay, so because our system is different, so when Bruce is decoding my message, he also need to convert it. If I send him any coordinate, let us suppose I send him 1 comma 2 only. So for him 1 comma 2 is not here. For him 1 comma 2 is somewhere here, right? For him 1 comma 2 is here. For Bruce 1 comma 2 is here, right? So he also need to convert this vector. So how he will going to do? He will do the exact same process. He will follow the exact same process, but instead of using this vector, sorry, this matrix for the conversion, he will use the inverse of this matrix. All right. So he will take a vector from the standard system VS. All right. and he will transform this vector using this matrix, the inverse of original matrix, and then he will get a vector in his system. Okay, so you see, from moving from Bruce system to standard system, we use this matrix, and from moving from standard system to Bruce system, we use the same matrix but the inverse of it. So let's see one thing. Uh, we have this vector -1, 2 and 1, 2. So these are the same vector, right? These are the exact same vector, but their numeric value is different because we are using two different basis sets, right? So we transform this vector -1, 2 in this basis system, and we get 1 comma 2, right? We get 1 comma 2. So -1 comma 2 is nothing but 1 comma 2 in the standard system. So when we convert this vector 1 comma 2 from standard basis system to Bruce basis system, we should get -1 comma 2, right? Because these are the same vector. So let's see if we are getting that or not. So as I already stated, to convert a vector from standard system to Bruce system, we need to transform that vector using this matrix. So the inverse of this matrix is the same matrix. So inverse of this matrix is -1, 0, 1. So this is actually a special type of matrix where A inverse, that is the inverse of the matrix, is equal to A only, the same matrix, right? So this is the inverse of the matrix, and we take this vector that is 1 comma 2, uh, that is uh, that is this vector 1 comma 2, and we transform it. And if we do this matrix vector product, then we will get -1 comma 2. So you can see that we transformed this vector 1 comma 2, we transform this vector 1 comma 2, and we get this vector -1 comma 2, right? So yeah, indeed, this is true. So this is how we can convert the same vector from one basis system to another basis system. So we have seen both the ways. We transform this vector -1 comma 2 from this system to this system, and we did vice versa also. We transformed, or we uh, check what this vector 1 comma 2 is in this system. Okay, so that's all for this video. If my videos are helping you understand these concepts, please give them a thumbs up, subscribe to the channel, and share it with others who might benefit. That's all for today. Thank you. Bye.